graphing. And since I have a lot of different people in here that I don't usually teach, I don't know where you're at. We're going to just start at the foundations, okay? I find that even experienced folks mess up on plotting points and things like that. They get confused, especially once they start learning more things in algebra. They start wondering, wait, do I go up or right or left or down, when, so forth. So we're going to start talking about the anatomy of a Cartesian plane, a graph, right, with 4 quadrants. And we're going to just talk about those things for a little bit, and just so that we understand them. So first of all, the kind of graph we're talking about is a Cartesian plane. Cartesian plane. And I can't remember the name of the guy, he's something like that. That's plane, sorry. Cartesian plane, Cartes or something, Descartes or something, was the guy that came up with this method of graphing. Great. So, let's see here, I guess I'll do it here. So we're going to have a big graph here. So this is my x-axis, this is my y-axis. Okay, so with a Cartesian plane, there are 4 boxes, so to speak here, right? And we've got to start to identify what different parts there are to this graph, because eventually you're going to become extremely good at these. Extremely good at these. And I'm going to give you whiteboards eventually, and I'm going to say, graph something, and within less than 10 seconds, you're going to be graphing things for me. Rather complex equations, and you immediately, within under 10 seconds, you'll be able to graph them. But for now, we're going to start at the beginning, so easier, and then tomorrow we're going to actually get a little more complicated, and then Thursday a little more complicated, and then Friday a little more. So, so Zane. Did you really?
Oh, yeah.
Oh, that's so cool.
Yeah, I was shadowing.
Really? That's so cool. Yes.
Because you kept on talking about rise over rise.
Right.
Rise over rise.
Okay.
Is so fun. Oh,
Yes. Manu.
I forgot.
Okay, well think about it. I'll call on you again when you remember. So there are 2 axes. This is called an axis, the y-axis. So this is called the y-axis. And this is called the x-axis. And if you were ever going to talk about plural for some reason, it would be axes, right?
Why would you have?
And I don't know why you do that, except unless you were talking about a lot of different graphs that have y-axes, right?
Or
and you're trying to compare the.
Or when like those graphs that are like flat here, and then
maybe.
there's like a blue on this side and a red on this side, and they're 2 different y-axes.
Yeah, maybe. So, some people, by the way, Cartesian plane, some people call it also the coordinate plane.
Oh, I know that. Cartesian sounds better.
Okay, and then, so we know the y-axis is vertical, and you just have to memorize that. So I think of it as like y is like a fly. Y flies, and I think of x. You know how like when you were a kid, you couldn't wait to find the treasure map with the big X, where the gold is buried. Well, the gold is always buried in the ground, not in the sky, right? So I think of X as where X marks the spot on the ground, and Y goes up and down like a fly, right? Does anybody else have a better way to remember it? Yes.
Maybe Y is long and it goes down and up. That's fine. X is like a box.
All right,
And
Zane,
X,
you had one?
I do have one, but it's about like doing like X like 13 columns. When it's graphing, it's like 13 column 5. Like so, X comes before Y. You walk before you fly.
Oh yeah. So you walk before you fly. So he's talking about actually plotting a point, and so that's good. We'll use that in just a little bit. Okay, Jake.
Another thing to think about.
Guys.
Y is a jerk. He always looks down on X.
Get it?
Get it? 'Cause he's
Unless he's down
X is
here.
also looking down. X is
Unless
looking
he's
down
down
on
here,
Y
then he's
because
looking
Y
up.
also knows it.
Yeah,
Well, yeah, but you know what I mean.
Yeah, but that's not a bad, that's actually pretty good, actually. Y looking down at it. That's good.
That's why I
This is a complicated way to think of it, but like X has like a curve at the end usually. Like
We're so
part
bad
of
at
it,
math.
at least on the left and the or right, or yeah, right bottom. So I always like look that up to be like the x-axis. Think of it.
Cool.
I
Alright,
know.
that's
I
cool.
don't know
No,
why.
that's cool.
think
I
of it
see.
like that.
And then Maddie, do you have one?
I like
So you just think of it as the Earth and like, or the ground on the Earth. It starts right at the x-axis, and you can either go down or you can go up on the bottom.
Yeah, okay, good. Awesome. So, in addition to the axes, there are 4 quadrants. This is quadrant 1. Quadrant 1. And the way you do this, quadrant 1, you do it in a Roman numeral. Now, a lot of people think, quadrant 2's down here. It would make so much sense to go clockwise, but no. For some reason, they go counterclockwise. So this is quadrant 2, again in Roman numerals. This is quadrant 3. And this is quadrant 4. Okay? Then, with graphs, usually, you have grid lines. Would have probably been a good idea to do it on this, but I didn't think of that. But, so then you have grid lines. These are called grid lines. And you just sort of have to assume, like with graph paper, these lines kind of go forever, right? Left and right. So those are the grid lines on the y-axis. They're all going forever, infinitely to the right and the left. And we'll use those. And now for the x grid lines on the x-axis, those are going forever up and down. Does that make sense? You see what I mean? Like graph paper, right? Yes, Maddie. Yes. Okay. And then you have a point where the 2 axes intersect. What does intersect mean? Jackson. Meet. Where they meet, right? Where they actually touch. All right. And that's this point right here. And that point is called the origin. This is called the origin. Origin. And that's a really, really important point, because that's the point that you always start at when you're plotting points. You never start somewhere else and plot a point. You start at 0, 0, and then you work your way, to different things. So, John, you're taking notes? I want to see your notes today, okay? I really want to see them afterwards. It's got to be, everything that's on the board has to be in your notes. I just have to be sure. Quadrant 1, quadrant 2, quadrant 3, quadrant 4, origin. Let me think, is there anything else I'm forgetting? I don't think so. And so, yes?
Can it range, do the numbers on the graph, like the lines, do they range from any number they want?
Oh, that's a good question. So, typically, in the beginning, when I'm first teaching graphing, usually, I go 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, right, and so forth. And this would be -1, -2, -3, -4, -5. So really, this is like a vertical number line, right? Like, our number, this would be -1, -2, -3, -4, -5, so forth, right?
I thought that it only went up to 9 though.
Well, it can go up infinite. These things can go forever and ever and ever, right?
Yeah.
Right? So I could just keep going. If you're patient and wait for me, I could actually go up to 10 billion. You want to watch me?
Yeah.
No, thank you.
Okay, great. Thank you. Whoever said no, thank you. Thank you. You saved me. But right, so these go on as far as you need them. Now, sometimes when you're graphing in the millions or something, right? And so 1, 2, 3, 4, 5 doesn't work so well. But you could say 1 million, 2 million, 3 million, 4 million, 5 million. See what I mean? That's what that space could represent.
The origin is always zero.
The origin is always that. And
So is the origin only zero?
Yes.
well, let me explain that right now. I'll go through it. So now what we have to do is talk about a coordinate point. A coordinate point. And these have different names. Coordinate point, or it's called ordered pair. Have you guys heard these?
Yes.
Ordered pair. And it's always has parentheses around the point, because that sort of tells you that we're talking about a point. It's sort of one way that it sort of defines it, sort of. And then you have a number in the first, and I'm going to put an X there for now because I don't know necessarily what that number is, and a Y in here. Whenever you write a coordinate point, the first number it's like a map, and the first number tells you how far to go along the ground, right, to get to your destination. And the second number is your Y. It tells you how far you fly to get to your final destination. But think of a coordinate point as a map, right? This is really a map, and it's sort of like a GIS system, like
GPS.
or GPS. That's what I meant. GPS system on your phone, right? And so it tells you go turn right here and turn left there and turn whatever. It's the same thing. It's in map. It's on for a graph. So if I gave you the point 0, 0, that would mean I'd start at the origin. Remember I said that? You always start at the origin. And it says for my x here, the first number is x, I go nowhere. And then for my y, I go nowhere. So I stay right there. So that's my origin. My origin is 0, 0. That's my origin. Does that make sense, Dee Dee?
Mm-hmm.
Okay? And so every point,
So is the origin zero, but is it always zero? Like
it's
so-
always 0, 0. For the origin.
Okay.
Yeah, for the origin, yes.
And then
There are,
you can do it.
there are confusing things because with graphing is one of the reasons that corporations and businesses and different people can lie to the people. Or not really lie, they can deceive the people legally. Because you can make something look, guys, you can make something with a graph look radically different than reality.
3.14.
Right.
If you did it like, it starts out as like 3.5 and it ends up being
Yeah.
3.7 at the end. You can make it look
Or like it
So-
Technically, you're
Right,
not
so
lying.
I'll
you're just
maybe
manipulating
towards the end of the week, I'll actually give you some examples of how you have to be really careful when you see a visual in a magazine and somebody's proving their point that Pepsi-Cola is selling way more than Coke, right? You know, right?
Pepsi is disgusting.
So, well, I'll show you some of those examples. But guys, this is a video, so let's come back to the video. I'm going to give you a chance. I'm going to stop the video in just a little bit and give you a chance to do some work in class and practice this, and then homework. Then I'll give you the homework after that. But so let's talk about plotting points. So when I plot a point, okay, remember it's x comma y in parentheses. Every point on a graph has to have an x and a comma and a y. I mean, it's got to have a value for x and then a comma and then a y, value for y, and then parentheses around it. So if I gave you 2, 5 as a point, I would start at 0, 0. Always start at 0, 0. And it says, like this is where what Zane was saying, is this is your x. Your x is what you do, you walk, right? You walk along the ground with your x. And you walk before you fly. But then for your second number, you fly, right? So I'm starting at 0, 0, and it says I have to walk.
It looks like a face.
My map says I have to walk
like an
2
owl,
paces to the right because that's 2, positive 2, right? Positive 2 is to the right. So I walk 2, but I do not put a dot there yet. This is just my map. It's telling me how to get to my final destination. I still have to do my 5, then I fly for my 5, so I go up 5. 1, 2, 3, 4, 5, and I put a dot there. That's my final destination. So that is 2, 5. I think most of you know this, but I don't know for sure. So it's good to just get a good foundation in it. And then we'll be using this a lot starting tomorrow. Yes?
I have a question about the negative, positive in the quadrant.
Okay.
Quadrant 2 is negative, positive, right? And then quadrant 4 is positive, negative?
Quadrant 4 is yes.
Okay.
Yeah. We're going to talk about that in just a second. So notice, okay, let's do a couple more in this quadrant. Let's say I have 8, 2. All right? So again, I start at 0, 0, and the very first number is what I walk. I walk along the ground. I go to 8, 5, 6, 7, 8, but I don't put a dot there because I still have to fly 2. So I go up 2, and I put my dot at 2 up there. That's my 8, 2. Now, are these numbers positive?
Yeah.
They're all positive. That's interesting. So to be in this quadrant, quadrant 1, it's always going to be a positive number, comma, a positive number. Make sense? Yes? All right. But what if I gave you, I like to write higher than lower. Okay, so how about I gave you -4, 6. So I'd start at 0, 0, and it says I walk -4. So -4, I go 1, 2, 3, 4, negative. But I don't put a dot there. I still got to go up 6. Up 6, boom. Put a dot up at 6. Okay, that's -4, 6. All right. We'll do one more in this quadrant. How about -2, 1? Start at 0, 0. I go -2, and I go up 1 because 1 is positive. Up 1, put a dot. So that's, what is that? -2, 1. All right? So in this case, my x's are negative, right? So in order to be in quadrant 2, I'm going to have a, whoops, excuse me. I'm going to have to have a negative x, comma, and a positive y. Does that make sense? Johnny, do you see that? Make sense? Okay. And then quadrant 3. Let's try quadrant 3. Whoops. Didn't mean to erase that. X, comma, y. And so I've got, how about I do -5, comma, -4. Okay? So I started 0, 0. My first thing says I walk to -5. -5 is over here. And then I fly to -4. Well, I can't fly positive. I can't fly up if it's negative. It means I'm flying down underground, right? So I'm falling, really. So -4, and I put my dot there. Okay, so that's -5, comma, -4. So I don't have to do another one. Tell me, what is it? What's this quadrant going to be? X and Y are going to both be negative. So it's going to be negative, comma, negative. And over here, I mean, that one's kind of pretty obvious now, probably. But let's say I did 6, comma, -4. All right? So I'm going to start at 0, 0, and I go over to 6, down -4, boom, around there, put a dot. And that's 6, -4. All right, great. So that's basically plotting. So somebody tell me what this point is right here. this point right here. Raise your hand if you know what that point is right there. 5, right there on the x-axis. So, Bella.
5, 0.
It's 5, so I start at 0, 0. I go to 5, but then I don't go up or down, so I got to say that. I got to say 0 is the y. So it's 5, 0. All right, how about this one? How about this right here? Somebody else, give me. Somebody else. How about anybody else? Somebody else, I don't see hands up. We're out. This one. Jax, you know this? So this point, what would be my x? I'm starting here. How far to the right or the left do I have to go to get to this point? Nowhere, right? Right? Because I want to just go straight up. So I say my x is 0, right? And then my y is 1, 2, 3, 4, 5, 7, right? So it's 0, 7. That make sense? You get that? So what about this one? How about this point right here? How about that point? Aiden. What point did I just do? This one, right?
-5 and 1.
Yes, good, awesome. -5, 1. How about this point right here? Somebody. Okay, Isa.
1, -5.
Yes, good job. Excellent. So you guys have this down, right? Now, how many people have actually, is this new for anybody, just so I know? Or has everybody been exposed to it? Everybody's been exposed to it, pretty much? A little bit? Okay. But regardless, I'm going to just stop this for now. I think that's all I needed. Let me just quickly look at the homework. I just got to remember what. I kind of had seconds to pull this homework together, so, oh wait, so what I'm going to do, we got a little time, I'm going to